This video shows the design of a 4x1 multiplexer using 2x1 multiplexer in Cadence Virtuoso. For the design of a 4x1 multiplexer, I'll use the already designed 2x1 multiplexer using transmission gate logic. To create a multiplexer, first create a new cell. Name the cell with mux 4x1. I'll use the instance which I have already created, which is a 2x1 multiplexer. Copy this instance. To create a 4x1, I require 3 2x1 multiplexers. Connect the first output, second output, name the output as Y, connect all the VDDs. Similarly, connect all the grounds. And we have the selection signals here. Create the pins for 4 inputs D0, D1, D2, D3, S0, S1. All these are inputs. This is for D0, D1, D2, D3, and I have the selection signals. Both the selection signals should be connected. S0 and S1 I am placing here. Make the connections. Connect this selection signal. Output. Provide the VDD and ground pin. Check and save the design. Then create a symbolic view. Go to create cell view. From the cell view, click OK. Click on OK. It opens the symbol editor where you can create your own symbol. Let me delete this so that I can create my own symbol out of it. Or let me keep as it is. Delete this part number. Place the ground, VDD, and Y. You can rename this with mux 4x1. Create selection box. The design is completed. Close the design. Now to simulate this 4x1 multiplexer, create a new cell and name it as sim or test. Get the instance of 4x1 symbolic view. Provide the inputs. Let me copy the I want total 6 inputs. And I can make the connection of this in this manner, or I'll use the pointer. Let me make the direct connections. And this one. Now it's okay. These two are for selection signals. Provide the VDC, which is a supply. And output pin is Y. Provide the ground here. Make the connection of it. Now the design is completed. I want to name them. So let me check the pulse which I have provided. Pulse width is 5 and period is 10 nanoseconds. And this is 10. Make the period of the pulse as 20. Similarly, for the other inputs, 20 and make it as 40. For this one, we can change this to 40 to 80. You can define your own width and pulse or make it as 30, 60. These two are the selection signals. Press Q and make the signal to 60, 120. This one also same 60, or you can have your own 120, but I'm reversing the voltage from 1 to 0. You can rename the nets like D0, D0, D1, D2, D3, S0, S1. D0 is the input, D1, D2, D3, S1. Check and save the design. Go to the launch, click on ADL, right click, click on edit, select the analysis to tran. I want to simulate it for 250 nanoseconds. Right click, I want D0, D1, D2, D3, S0, S1 and output Y to be plotted as the responses. Click on netlist and run. So this is the total output and these two are the selection lines. For various combinations you'll get the output. Like for S0, 0 and 1, in this duration 0, 1 combination, I'll get the output of D1 totally up to here. You can change these pulses so that you can see the differences. Only two combinations are there. If you want more combination, you can go with that. Or let me change and show that. I'll go from 120 to 240. Check and save the design. Now simulate the design again. This is the output Y for different. For 0, 0, I'm getting this as output in this region for 0, 0 combination. 0, 0, then I'm getting this.